Hi, mathematicians. Over the last couple of classes, you've discovered and justified a lot of exponential patterns. I have them over here just summarized so we can use them as a reference. In this video, what we're going to do is we're going to use these patterns to simplify two complex exponential expressions. I have them here. We're going to simplify this one and then that one. What you might want to do before we go any further is pause me and just give them a go yourself and see how you simplify them, what you get, and then come back and compare. These types of simplifying, you can do them in lots of different ways, so it might be interesting to do a little comparing and contrasting how we do that. I'm going to start with the first one. And what I tend to like to do is I want to first handle these parentheses here. So I know I have a product that's being raised to a power. So that's the same as 2 cubed times x cubed, and I still have my y to the negative 3, all over 4 times x squared. As I do this too, I kind of like to group my numbers together and then my variables together. It helps me think through this. Next, I'm going to go ahead and just get a little arithmetic done. So I have 8 over 4 times x cubed over x squared times y to the negative 3. That's all over 1. This is something I do. You don't necessarily have to do it. I sometimes I just separate it out into separate fractions, just so I can, again, really focus on the different pieces of this. I know here I can divide out a common factor of 4 and be left with 2, common factor of 4 and be left with 1. When I'm looking at my x's, I can divide out 2 of the x's. That's going to leave 1 in my denominator, and it's going to leave a single x in my numerator. And then finally, I'm going to, in the next row, take this negative exponent and write it as a reciprocal using a positive exponent. So I have 2 over 1 times x over 1 times 1 over y cubed. A reminder with this negative exponent, we can write this as a reciprocal using the positive exponent. My last step is I'm now going to multiply this back together so I can write it as a single fraction, 2x over y cubed. If you paused me and tried it, did you get the same thing? Did you go about it in a different way? Again, there are many different ways to do this. Let's look at the next one. For this one, before I want to raise everything to the third power, I definitely want to simplify what's inside the parentheses. If I can make what's inside here as simple as possible, raising it to the third power will be also as easy as possible. I think the first thing I'm going to do, again, is kind of just separate it out. So I have my numbers, that's a 9, and my variables that are together. All right, so there's that. Okay, I think the next thing I want to deal with is this negative exponent. As a reminder, the negative exponent, it's just going to be written as the reciprocal with the positive exponent. So that will become 9 over 1 times, that is going to move into the denominator. We'll keep the y to the 4th there and be written like that. All right, did that seem like a little bit of magic? Let's take a little break and look at this more closely. Another way of thinking about this is as two fractions that are being multiplied together. Y to the negative 2 over 1 times 1 over y to the 4th. This is the same as the reciprocal with the positive exponent, and then we can multiply them back together. That's where this came from. Again, multiplication, we can do it in any order. All right, next step, let's look at those y's. They're being, powers with the same base. Let's add their exponents. We'll get y to the 6th. And then finally, let's go ahead and multiply these back together to get a single fraction. All right, that's much easier to work with. Now we can pause and deal with this exponent. We'll be distributing that exponent to both the numerator and the denominator in division. 9 cubed, y to the 6th, all cubed. And then lastly, we have a power being raised to a power, so we'll multiply the exponents. 9 cubed over y to the 18th. This is a time where we typically don't go ahead and cube 9. That's going to be a really big number. We'll keep it in its exponential form. Mathematicians, I hope this video walking through these two examples helped you think through some strategies you can use to simplify complex exponential expressions. Please ask me if you have any questions, and the next step is you're going to be doing a bunch of practice. All right, see you soon.